So now we have lots of information about polynomials. So we are going to now talk about how we can graph them. So there are 6 main things you want to do when asked to graph a polynomial. Okay, the first thing you want to do is to find the intercepts. You may have to factor. If you get to the point where you have a quadratic, you may have to use a quadratic formula. Second thing you can look at is what's the symmetry. If it's even or odd, you could talk about, is it going to be symmetric about the y-axis? Can I flip it and turn it around the origin? Let's use the multiplicities to think if we have any bounces. What's the lead term telling us about the end behavior? You may have to plug in some points to actually sketch the graph, and then check it on Desmos. Now, you can't use Desmos on a test, but you can definitely check your work on Desmos. So here is a question on Alex. So look at all the pieces they've asked about this polynomial function. Now, what's great about it is that they have factored it for us, which makes our work, a little nicer. Okay, so the first thing it says to do is choose the end behavior. Okay, so let's take a look and let's pull out what the lead term is going to be. Now it's going to include any coefficients and only the x's and any powers you see, and there's no powers, so it's just going to be -1 times x times x times x, or -x cubed. Okay, so now that tells us about the end behavior instantly. It is going to act like a cubic that has been flipped upside down. Okay, so I know that the left end is rising, but the right end is falling. So we're talking about this one right here. So it is rising to the left and falling to the right. Okay, so that's what the lead term tells us. Now it says list each zero according to the behavior of the graph from at the x-axis near that zero. List each zero of f according to the behavior of the graph at the x-axis near that zero. If there's more than one answer, separate with commas. If there is no answer, write none. So they're talking about here, this is where we're referring to a bounce, and this is a pass-through. So that's just the way they've worded that language. So pass-through means crosses the x-axis. Touches but does not cross means it bounces. Okay. Now, if you look, there were no powers on these. Each one of those appears just once. So because of that, every single one of them is of this category. None of them are going to, are going to pass through the x-axis. None of them are going to bounce. So that's out. Okay. So that's a none. Okay. But let's take a look at what we know. So if we go to this function, x plus 1 equals 0 at -1, x minus 1 equals 0 at 1, x minus 3 equals 0 at 3. So we have 3 places that we cross through the x-axis at x equals -1, 1, and 3. Now the negative in front does not affect the zeros. It affects our end behavior. Okay, so now we've got that. The next thing they want is the y-intercept. Now the y-intercept is just plug in 0. Now when we plug in 0, we get the opposite of 1 times -1 times -3, which happens to have 3 negatives, which are going to stay negative. 1 times 1 times 3 is 3, so negative 3. Now it says, we're going to graph it. Plot all the points where the graph intersects the x and y axis. That is what we've already found. We are going to hit negative 1, 1 and 3. We're going to hit the y-axis at negative 3. So let's do that first. I've got some graph paper down here. Let's put those on there first. So negative 1, 1, and 3. And then we hit the y-axis, it says, at negative 3. Okay, so that's all I've done. I've just put on there the points we have found. We found the y-intercepts, negative 1, 1, and 3. And we have found the y-intercept at negative 3. Now it says, connect the points following the behaviors. Okay, so what does that mean? Well, this end has to go up. This end has to, wait, let's see, our end behavior. That one has to go down. So, and remember, none of these things bounce off the x-axis. So it's got to go through the x-axis. Come back up, go through the x-axis. Come back down and go through the x-axis. Now, there's going to come a time where knowing how high the bumps are, we kind of know how low that one is, but knowing the heights of the bumps are going to be important. Now, they're just having you connect them. So you would connect, down, up, you got it, okay? So that is how you graph it. I just need you to put on the intercepts and then the ends. What are the intercepts doing? What do the ends tell us? So that is everything about that graph. And let me zoom in on the graph there so you have it. So we're going to sketch these really fast, okay? That's our goal, okay? So find your lead term. So it's going to be negative 2 times x squared times x squared times x, which is negative 2x cubed. So the left end's up and the right end's down. What are the x-intercepts? Well, it's where x plus 3 equals 0 and where x minus 5 equals 0. So that's going to be at negative 3 and at 5. But this one had a 2 on it. That's even. So that's a bounce. We're going to find our y-intercept, and then we're going to graph it. Okay. If I plug in 0 for all the x's, I get negative 2 times 3 squared times negative 5. 3 squared is 9, times negative 2 is negative 18, times negative 5 is 90. Okay. So we're going to go over to the graph. Now for your graph paper, let's assume 9 is really counting that that's 90. Okay. We have an x-intercept at negative 3 and 5. The left hand's going up. The right hand's going down. Now at negative 3, we have a bounce. So what that means is when we get to the x-axis, we have to bounce, come back up. So we're going to bounce, come back up, go through this one. That's as accurate as I need you to be. Nothing more than that. The less points we have to plug in, the better. We need to be able to graph a polynomial quickly. And then throw that equation into Desmos. Does your bumps kind of match? Does the ends going in the right direction? That's it. That's all I need. Okay, let's do another one. Find the lead term. So that's going to be 1/4 x times x to the 4th times x to the 3rd, which is 1/4 x to the 8th. So both ends are going to be pointing up. They're both rising on the left and also on the right. Now, what are our zeros, our x-intercepts? Well, it's where 1/4 x equals 0 and x minus 1 to the 4th equals 0 and x plus 3 to the 3rd equals 0. Okay, so this is just 0. Multiply by 4 on both sides, you still get 0. This is where x minus 1 equals 0, which is 1, but that was an even power originally, so that is a bounce. Now x plus 3 equals 0 at -3. That was originally an odd power of 3, so this is a pass-through. Only other thing we need is our y-intercept. Okay, so as you can tell, even power, odd power, pass through. We have 3 different types of factors. We have 3 different x-intercepts. Now, last thing to do is plug in 0. When you plug in 0, you get 1/4 of 0 times -1 to the 4th times 3 to the 3rd, which is 0. If you get an x-intercept of 0, it's your y-intercept. Okay, so first thing, let's plug in our intercepts. So we have one at 0, one at 1, and one at -3. Okay, so now we have those. Now put on your ends. So put on your intercepts, put on your ends. Left's going up, right's going up. Now, don't forget, there's a bounce at and only at 1. Okay, so what does that mean? Well, we're going to go through, come back down and bounce. Okay, let me do that again. We're going to go through, come back down and bounce. Could we be more accurate to find how low we go and how high we go? I mean, it might go way, way down and way up. Yes. Do I care? Not in the least. When you get to a calculus class, then we'll care. For now, just go through, make a bump, go through, bounce. Okay, and so that would be the sketch of the graph. I don't need anything more than that. Now, if you want to plug in points, go for it. There's no need. If you want to, yay, go for it. Okay, let's look at this one. Now, it is not in factored form, so the first thing I would suggest doing is to put it in factored form. Now, do you see how it says approximate each 0 to the nearest 10th? That's if we get a quadratic or something that isn't factorable. We're going to focus on things that work and are factorable for now. Okay, we will get to things that don't, but for now. Okay, so these are both negative, and we can take out an x squared. These we can't take out anything, so write it as a 1. And then we're left with x plus 3 and x plus 3. Our parentheses match, so that means our x plus 3 is the factor that can come out, and a 1 minus x squared is left. That factors one more time to be 1 minus x and 1 plus x. Now, there's lots of ways to have gotten to that point, so do what you got to do. Okay. Our lead term is negative x cubed, which means the left side goes up and the right side goes down. We have 3 zeros. We have 2 turning points then, and they're all unique, so there's nothing but pass-throughs. So we pass through when x plus 3 equals 0, so at -3. We pass through when 1 minus x equals 0, or x equals 1. We pass through when 1 plus x equals 0, or x is -1. So let's put those points on there. So at -3, at -1, and at 1, our left end goes up, our right end goes down. We pass through every single one of these. So we pass through, come back around, pass through, come back around. Ooh, there's one little piece that I didn't put on there. My y-intercept happens at 3. I was pretty close. So we're going to go down, up, down. Now, if you want to make the bumps more realistic, you could plug in -2 and find out how low it goes. Don't care. I don't care at all. As long as you have all the intercepts on there. And there you go. Okay. So the homework. This is what I'm concerned about. Okay. So don't worry about the instructions. I need, what is your lead term? What are the ends doing? And just that little sketch like I was doing is fine. I need you to find all the x-intercepts. I need you to find all the y-intercepts. I need you to graph, including all of those, the intercepts, the ends, and any bounces. Okay, all of these can be factored in one way or another, I believe, and if they can't, then we are going to do them again. I'm a little concerned about 4, but the other ones I see are factorable. Okay, so there you go for that.